All right, so we are here and we're going to continue our talk about parallel and perpendicular relationships, but this time we're going to shift a little bit and we're going to talk about parallel and perpendicular relationships in 3D space. All right, so when you look at our next standard, those all relate to this, right? So I can determine whether lines are parallel or skew in 3D space. I can name planes to determine if points are in a particular plane. I can determine if planes are parallel or perpendicular in 3D space, and I can find and name intersections of lines and planes in 3D space. All right, so when you look at this, there's going to be a lot of commonalities with what we've talked about before, but we're going to add some new terminology to this. We're going to talk about some new definitions, but to get you started, I want you to think about a few things. So go ahead and, all right, go through the opener here, and you can pause the video and answer these questions. You may not know the answer to some of these, and that's totally fine. And the point is that hopefully we get to some understanding of these concepts where maybe you can answer these questions at the end of the lesson. So go ahead and give this a shot and pause the video and turn it back on and we'll see how you do. All right, so let's look at this, right? What is formed when two lines intersect? Well, what we hope you saw was that they intersect at a point. All right, and sometimes you can see this like within your window frame. Maybe you have some things on your walls that intersect. All right, and then what is formed when two planes intersect? So this would be like two walls, or your ceiling in the wall, or the floor in the wall. And what you get here is a line. All right. Okay, and then what is formed when a line intersects a plane? This is a little harder to see because you can think about what happens if you had like some type of form, all right, and it joins somewhere and it kind of goes through. Sometimes it's easy to think about like a pipe going through a wall, and if you were to take that pipe off, it forms a point, all right? So there's some different things that hopefully we'll go through that'll help you see this a little bit better. Find an example of two lines in the same plane that do not intersect. All right, so hopefully you saw that. And find an example of two lines in different planes that do not intersect. All right, and that's actually the difference between parallel and skew lines. All right, and we'll get to that in just a moment. All right, so now some common definitions that we need to go through here. Let me just move my dot camera around here. So point, line, and plane actually don't have formal definitions in geometry. All right, they're kind of undefined terms, but we kind of have a common understanding of them. All right, so a point actually has, and I'm going to just put here, has no dimensions. All right, it technically does not have any dimensions, yet we put a dot and usually a capital letter to denote, all right, a point. All right, and we kind of understand what that means intuitively when we talk about that. All right, so a line, right, a line segment or a line is something that extends, all right, in both directions through 2 points. All right, and so a line has one dimension. All right, and it extends, all right, forever through 2 points. All right, and so we kind of got into this a little bit before, but if we have a line, all right, we put 2 points on that line, and we usually put the arrows at the end, and that denotes that it's going to keep going, and we usually use 2 capital letters, all right, okay, to label a line. And now when we get to a plane, okay, once again, a plane has 2 dimensions. All right, and think about your graphing, right? That we call that the XY plane because we can go left and right and we can go up and down. So that's what we mean by has 2 dimensions. All right, and we think about this in terms of like a flat surface. We think about this like maybe a piece of plywood or an index card or a piece of paper, right? So we think about this in terms of some type of flat surface. All right, but this flat surface, all right, it extends in all directions. All right, so it just kind of keeps going. So if you think about your piece of paper, just imagine that continuing, all right, forever and ever. And think about, once again, your graphing, right? So we know in the XY plane, right, we can keep going up in values of X in the positive direction and the negative direction. Same thing for Y, right? So that technically that XY plane can keep going. So we typically note a plane kind of like with a, all right, parallelogram that looks something like this. All right. A lot of times, all right, you might see a lowercase letter to denote a plane. All right, so this could be like plane A. All right, or we might say there's a set of 3 points in that plane, and we use those 3 points. So X, Y, Z. So we'd say that's plane X, Y, Z. All right, and this is important because a plane is determined by 3 non-collinear points, and we'll get to that a little bit more in a second. All right, so 3D space. This now has, to create 3D space, we have to have, all right, we have to have 3 dimensions. All right, so we think about this, we have the X and the Y plane right here, right? So this is the X and the Y, and then now we give it, all right, what we call the Z plane, all right, where it goes up. So that creates our 3D space, all right? And that's what 3 dimensions mean, right? So we have the horizontal, the vertical, and, all right, the left-right aspect here. Okay, so intersection. This is just where 2 things meet. All right, that could be 2 lines. It could be a line and a plane. It could be 2 planes. All right. You know, and so kind of what we were talking about earlier, we think about something like this. We could have a line that hits that plane and then goes through, right? So this would be the intersection, right? Or we could have 2 lines, and we've seen this in algebra, that intersect at a common point. Okay, now skew lines. Skew lines. All right, so now we have parallel, we have skew. Now skew lines are 2 lines that do not intersect and are not in the same plane. Okay, and the best way I can think about illustrating this is, let me grab another pen here. All right, as you can see my 2 pens. All right, so we think about parallel, all right, same direction. All right, and we can see that if I wanted to, I could take these 2 pens, all right, and I could put a piece of paper on them and it would fit just fine. Versus skew lines, now if I turn the top pin like this, correct? So notice that they now do not intersect, but they're going in kind of what we can say different directions. And now I could not necessarily get one piece of paper to hold both of those pens. And I know that might be a little bit hard to see, all right? So you can see it looks like they intersect that way, but if I rotate, you can see that they don't intersect, right? Because they're not in the same plane, right? So if I kind of do that, all right? So that's what skew means. All right, and it's a little hard to draw, but they're just not in the same plane. All right, let's go back over, all right, here. So coplanar, all right, so coplanar means, if we think about all right, so you think about co-presidents, you know, co-leaders, all right, means together, right? So these mean points contained in the same plane. And that's what I was referring to earlier, right? So when we think about a plane, right, all these points would be coplanar. They're all in the same plane. All right, so collinear, all right, means points on the same line. And if you didn't know this, there is an infinite amount of points on a line. All right, so whatever points we determine, right, so those would be collinear. All right, all 4 of those points because they're on the same line. All right, a little bit more vocabulary here. All right, so if 2 lines do not intersect or are in the same plane, all right, that is parallel. Those are parallel lines. So they do not intersect and they are in the same plane. So think about what we've already been doing, all right, with some of our graphing in the XY planes. All right, if 2 lines do not intersect and they are in different planes, then they are skew lines. Skew lines, okay? And that was what I was just doing with the pens. All right, now it takes 2 points to determine a line. All right, points that are on the same line, like we said before, are collinear. All right, so points that are not on the same line are non-collinear. Makes sense, right? All right, points that are on the same plane are coplanar, like we just said above. And then points that are not in the same plane, all right, would be non-coplanar. A plane is determined by 3 points that are non-collinear. So basically, if you can take 3 points and draw a triangle with them, then you know you can form a plane. All right. And the reason why they have to be non-collinear, all right, once again, if I kind of hold up my pen, all right, I'm going to take my notes here and hold them up here. All right. If the 3 points are collinear, what happens is you can get an infinite number of planes that could rotate about, all right, that line. So that's why we need it to be non-collinear. Otherwise, we get an infinite amount of planes. All right, so now I'm going to go through a handful of examples with you. So we're going to kind of jump around a little bit, but we're going to go through naming a plane just real quick. And then we'll go through an example of some of this other terminology here. All right, so looking at figure 1 here. All right, so I know this is a little bit hard, and that's why we put the PDFs into the Schoology site. So if the figures are hard to see, you can open up the PDF and maybe get a clearer picture as you're working through some of these. All right, so when we name a plane, we use 3 points, and we said we need 3 non-collinear points, okay? And so what you need to understand is that there are multiple names that could refer to the same plane, because we can just pick 3 random points within that plane. So for example, when we look at the top of this box, I see for sure 4 points here, right? So I could name this plane as HGF. And notice, even with HGF, there are multiple ways to arrange that, right? With those same 3 points, I could have said HFG. I could have said GHF, right? So notice just with those 3 points, there's multiple ways to name the plane, right? But I could have picked another set of 3 points. So I could have said EGF, right? And then once again, you can see there's a lot of combinations with that, right? I could have said GEH, right? And so you can see that just from the top of this plane, right, there's multiple ways, all right, to name that particular plane. All right, so understand that there's not one particular answer with some of these questions. All right, so if you're checking your answers or you're responding, all right, notice that there are multiple answers. All right, so wanted to go through that with you real quick. Now, let's flip over to page 105 here. Sorry, I don't think I gave you page numbers earlier, but we're now going to be on page 105. And I'm actually going to go through example 2, all right, because I want to hit some of these vocabulary words in context with a 3-dimensional figure here. And this will be the end of our video today. All right, so now, once again, if you're having a hard time seeing this, all right, open up the PDF, all right, and look at that. Okay, so now, name 2 line segments parallel to PA, all right? And so PA is this back line back here. So now remember that parallel means they're in the same plane and they do not intersect. All right, so if I look, PA is in this bottom plane right here, kind of the base of this shape here. And what I can see here is, I believe this is KC right here. All right, is, all right, parallel to PA. All right, you guys with me on that? All right, because they're in the same plane, which would be this bottom plane, and you can see that they do not intersect. So KC, and I hope I can see that right on my picture here. All right. Now, I'll give you 30 seconds. You can pause the video and see if you can find the other line segment that's parallel to PA. All right. So now if we look, PA is also in this back plane right here, right? It's kind of the back wall. And we can see that this top line here is also parallel to this bottom line segment here. So I think that is GO there. All right. So that's what parallel means. All right, so now notice on part B here, we want to name 2 line segments skewed to PA. So what we want are 2 line segments that do not intersect PA, but are in different planes. All right, so I'm going to give you one here. So notice GK right here. All right, so you can see that GK is not in the same plane, all right, with PA, and we can also see that they do not intersect, right? Okay, so GK would be a line segment. All right, that would be skew. Same thing, I'll give you a second to find another one. All right, so go ahead and pause the video and see what you can do. All right, so hopefully you saw in a very similar fashion, we have OC over here, right? OC right there. All right. Okay, now name all planes that contain points O and G. I'm not going to name all of them. All right, well, I guess I can. We'll see here. So OG, notice, is this top line segment here. And so that could be the back wall here. All right. So I guess I'll name this as GOA. All right, so that would be the back wall here. All right. Now notice there we have the slant kind of plane right here. All right, and that would be GOC. And I believe that's all we can get from this particular picture. All right, so not too bad. All right, so describe the intersection of plane GPK, so that would be this left triangular plane here on the left side here, and ACK. All right, and that would be the floor here. So if I think about where does this side and where do the floor join together? All right, and that's really what we mean by intersection. So where are they joined? And if you can see that they're joined together at PK right here, at this line segment right here, right? That's where they kind of come together. All right, so typically, most planes intersect to form a line segment. Okay, all right, so now our OAK, so here's OAK, are they collinear? All right. And when I look at that, what collinear means is, can I draw one line through OAK? And the answer is no, right? Because I'd have to draw, you can see I have to draw OA is a line segment, but then I'd have to draw another line to get from A to K. So I'd have to have two line segments, all right, to form that. So that's definitely not collinear. Now, are they coplanar? Remember our definition of coplanar. If, right, they are three non-collinear points, I can draw a plane. All right, and that is the case here, so this would be yes. All right. Our planes A are OAC, so OAC is this right side here, and OGA is the back here, all right, are they perpendicular? And we can assume so, right? It looks like they are, and we have some right angle markings here, right? So it looks like they join, and really we're not trying to fool you, so if it looks like they're perpendicular, all right, they typically are, right? So we're assuming that this is perpendicular there, all right? Okay, our planes AOC, which again, the right side over here, and PAC, all right, which is the floor. And once again, yes, we're going to assume, right, that that is perpendicular, all right, to the floor. All right, most walls are, right? So we think about that. Now, our OA and AC perpendicular. And once again, we can see that there is a perpendicular mark there. We have that right angle symbol. All right, so the answer is yes. All right, so there's your introduction to, all right, 3D space. So go ahead and wrap up the rest of this lesson, and we'll see you next time.